Hi, I'm Luke Perkin, the developer of Wired, an upcoming VR title where you get to own your very own modular synthesizer, like this. Now, some of you will already know what a modular synthesizer is, but for those uninitiated, it is a build-your-own sound-making machine. It's made up of a series of modules, such as this, that you can wire into each other to create your own sounds. What I have here is a theremin, and you can see that this axis controls the pitch of the oscillator, and the distance controls the volume. And this is going into this speaker here. For my left hand, it controls the bottom oscillator and volume routed into this speaker here. So let's see what else we can do in Wired. I have a small collection of modules right now. Obviously the most important one is the oscillator, which is what I've just shown you. Here. Let me unplug these for now and bring the speaker over here. We'll see what I can do. So the main knob controls the pitch. This one controls the shape. And this one over here will morph the shape into various distortions. Let's get another one. Now the great thing in Wired is all these knobs and switches can be driven by other modules. It's as if you've got an automated pair of hands to turn those switches for you. It'll be a lot easier, actually, if I show you the LFO first. So the LFO stands for Low Frequency Oscillator. It's just like this, except it's a lot slower, so you don't get anything you can hear. We'll still plug this in. The frequency is way below the human hearing range. However, I can wire it not into a port, which you see on the sides, but directly onto a dial. Now this little dial here will control how much oscillation, or modulation I should say, will drive it, which you can see with the green outline here. Now, I can go past the 12 o'clock position and the modulation indicator goes red. It's now inverting it. Let's try it with this ramp. Listen to what happens when I start to turn up the frequency of the LFO. Let's make a little tune. So go back to my library of modules, and I'm going to get the sequencer. Now the sequencer has a built-in clock, and it's going to step through 8 of these steps. And I can move these faders up and down to generate a tune. So I'm going to plug the first pitch into here, and to make this not sound so harsh, I'm also going to get a filter. Now the filter filters out specific frequencies. I can drive the cutoff point of the frequency here, and then I can decide, do I want everything on this side, the high frequencies, the low frequencies, or a band of frequencies in the middle? I'm going to go for the low. And don't forget, everything is modulatable. Now you notice that this oscillator here is oscillating at a different rate to the clock in the sequencer, so I'm going to try and sync these up. So I'm going to take the square wave out of this one and tell this to drive it. And then I'm going to sync these two oscillators up. At the bottom we see a gate sequencer. So whenever it passes a green lit button, it's going to send an on signal via this cable. And you notice that these faders are grouped in twos, so I can get the second of each, plug that into a separate oscillator. Make a bass line. Can quantize these to the typical pitches you'll find on a piano. So I'm going to select C, E, F, and A. Create a copy of that. Maybe try that. So I'm going to first route this through to the quantizer. I'm going to take the output. Same with this. Let's bring in some more modules. Let's take a delay. Now typically you put a delay towards the end of the signal chain. So this is taking the signal and then delaying it into the future, and then mixing that back into the original signal. Nice thing is, and this is the duration of the delay, but you really start to get nice effects when you sync it to our clock. I'm going to show you the oscilloscope. So the oscilloscope projects a laser beam, and I can drive the position of the endpoint of that laser. So what you see there is a shape generated entirely from an audio signal. We have one signal driving the horizontal axis, and another signal driving the vertical axis. I can also drive in a different. And you can get some really interesting shapes. Let's drive this. Let's see what happens when we change the duration of the delay. Notice we can also modulate the colour. I'll make this a square wave. But before I'm going to plug it in there, I'm going to take attenuator, which all it does is a volume control basically. There we go, we've got a 3D structure. Well, let's see if we can just make a simple circle. Unplug this for now. To do a circle, we just want an unfiltered sine wave. There you go. Alright, I hope you've enjoyed this little sneak peek at Wired. Follow me on Twitter, LocoGameLuke, for future development updates, and also follow the YouTube channel, as I'll be posting more stuff there too. Thank you for watching.